um, machine learning models for large-scale product classification. Presenting is Dr. Ravindra, Ashendra, and Manas. Ravindra's already here.
Good afternoon to you all. We are going to discuss about two machine learning models for classification of product information. It's based only on text. Supposing some description information is available and which is a short text, and can we really classify into directly into a vertical? I will define each of those terms. So this is the total presentation plan. We are three presenters. I will only give overview and some of the terms that we use in the presentation. Then followed by me, Manas will present the part one, which is the seller side story of vertical classifier. So how do we really onboard a particular product by managing to avoid manual effort? Can we do it fast? And how do we do that? And Ashendra will cover the second part, which is the buyer side story, where he can also, can he really identify even taxonomy down the line? This is what Ashendra will talk about. This is overall, we are going to cover these three aspects: the problem statement, challenges, solution, experimentation, and results. And part one is an in-house development at Flipkart by Manas and me. And part two is by Ashendra, has done in collaboration with University IITK. Let me define what is catalog. Catalog is a systematic list of items. There's a dictionary meaning. Okay, that is typically we have, you know, that when you come to Flipkart and you try to buy certain items, we have millions of items for you to buy. And then we have to somehow manage to keep them in a systematic way. You have to group them meaningfully. So that meaningful grouping is called category vertical, and is also called vertical. So now on in the presentation, in the subsequent presentations also, we are only going to call it as vertical. Okay? And product is the most granular thing. And how do we really form vertical groups? It is governed by what is called vertical definition. Depending on the nature of products, they are all grouped through a meaningful group. Some examples can be something like shampoos, or that can be a vertical. And the moment you go to higher abstraction, that can be like healthcare products. Okay, that's kind of abstraction will be there. And this is governed by, say, I said, vertical definition. And those verticals are group of products. And in turn, groups of verticals which are of similar nature are at a higher abstraction. This is how the entire thing is going to be arranged. And each product will have a host of information, like its attributes, and maybe something like if it is a face cream, it has how many ml, how many grams, the sort of information, and a description, which is a textual description, which can be short or it can be long, depending on the seller. I'm going to discuss about some of those challenges. At this stage, let me also say why it is required at all, why this vertical classification is required. Typically at Flipkart, and of course in any e-commerce company, hundreds of thousands of products gets onboarded weekly when you see a lot of products get onboarded. Typical process is a seller gives, when he wants to onboard a particular product, he gives list of information. He tells what is the product about, and there is also a prescribed format or information that he is supposed to provide. And once he provides, a domain expert from the catalog side will have a look at that and tries to identify what is the natural vertical for that or vertical group. This is a manual process and it takes time. Supposing, imagine you have a solution, the moment you look at the description without having to look at all the category vertical attribute information, if you can directly assign a vertical with a high accuracy, you have saved all the time. And also a human bias from a domain expert to domain expert, the kind of feeling you have. So the moment you see the shampoo, is it different from conditioner? It depends on your domain expertise, and human bias will be there. That also could be avoided in this process. Okay, this is the basic requirement. Now we'll go to some example. This is a typical, I have taken a weighing scale example. I have also chosen some brand just to illustrate. And you see all this information. How many colors are there in the weighing scales? And features like display, and then is it in kg, LBs, how many sellers are available, description. And description is a detailed description. Now let us imagine you only want to depend only on this description, want to classify the product. So it reads like this. It's difficult for you to read from there. I'll just read out. It is to keep a check on your body weight and track it on a regular basis so you can guard your health against obesity and so on. That's how it reads. It doesn't really speak anywhere that it is a weighing scale. It is only qualifying that particular product in some sense. Okay? And if it is a standard product, possibly this information may be available to the manufacturer itself. Some may not be standard products, something like mobile covers. It is left to a seller to describe in his best ability. Then you have varieties of sellers who have different literacy levels and seriousness that he may put in to provide this information. Okay? Supposing I have a classifier which can classify, this is a kind of hierarchy I will get in. So it comes under weighing scales under the product vertical group called healthcare devices and the broad super vertical called healthcare. Another example. In this case, I have taken a conditioner, and this again has all the host of information. Now let us imagine I only want to depend only on this. In case of part 2, in the second solution, we make use of title information also. In part 1 solution, we only take a short text. Again, this reads like this. Is fuzzy, unruly hair getting the better of you? Then go ahead and grab this brand conditioner. This is how it reads. Again, conditioner has appeared here. It's not necessary that it need not appear as well. So now, when a classifier, supposing when it works, so through a model, based on description, can we really find a model which can classify accurately? Now, this is the list of verticals that are possible, and the classifier is supposed to work at hierarchical level. One is healthcare, to hair care, to conditioners among them. Okay? Ultimately, in summary, this is going to be a hierarchical classifier. Every node is a classifier in turn, and we had run cases on different data sets. We trained our model on Flipkart dataset and tested on both on Flipkart dataset as well as public domain like aggregator dataset, and it gives very good accuracy. At this stage, I think the other thing is data challenges. As I said, different sellers are sensitive to this data. How do they form that information? Some people just give a list of words. They are not complete sentences as well. It's not like object to object predicate also you will not have. Some people will have. In fact, those two examples what I have taken is quite a rich information that is there. It's very good. And when such information is not available and it is full of special characters, it won't be available even. From that sense, how do we really make sense? How do you generate this abstraction or a model? This is the challenge. And the need for solution I have already discussed. So at this stage, I will hand over to Manas.
Thank you, sir, for your context. Hello, everyone. Excuse me, sir.
Yes, sir.
Yeah. We'll begin with the problem statement. We had a very clear and precise problem statement stating, given a product description, we had to classify the product to an Flipkart catalog vertical. So let's discuss why the solution was needed at all. Now, vertical is an internal Flipkart catalog entity. But currently, while listing a product, seller has to provide the vertical of their product and provide data and attributes related to that vertical. Now, this can come as a blocker for seller who has thousands of products to sell. Suppose a seller has thousands of products. Now, for each product, he will first identify the vertical and then provide attributes for that vertical. Also, we had cases like some of the where data provided by some of the seller was misclassified. So in that case, we had to manually correct the vertical. So this involved manual interactions. So this is our broad solution outline. We start with the data preparation. All the data needed for training and testing of our algorithm was obtained from Flipkart catalog. Then we move to data cleanup or pre-processing. So in text classification, we had a very huge vocabulary provided by all the sellers, as there is no fixed format for a description. So it was very important for us to clean the data and bring a formal structure to it. Then we move to pattern representation, where we convert the text description to feature vectors, which was followed by feature selection. In this case, we selected a subset of features to reduce the vocabulary and mute or filter out the features which do not help improve the model and require more data. Then finally, we had classification and evaluation. Now, talking about data preparation. So one of the challenge we faced here was the number of products in each vertical were completely imbalanced. Some of the verticals like jeans, t-shirts, bedsheet will have products in range of millions, while some like toothpaste, mug will have hundreds or just thousands of data. Now it was very important for us to select a subset of the product description available so that it completely represent a vertical. We didn't want to miss out some description which might uniquely identify a vertical. So how did we try to solve this challenge? We started with grouping similar description within a vertical, clustering them together to bring together all similar structured or similar meaningful descriptions, and then take k best representative out of them so that it can still represent the entire vertical. One thing which is very important here are the outliers. Now, some unique seller might be only selling a product in one vertical and providing unique descriptions. So we also want to capture those descriptions. Data cleanup. Now, as we already discussed, there is no fixed format for how a seller should provide his description of the product. Some seller will just dump their entire product data. Some will give comma-separated keywords, and other have their own format of giving. So we started with small techniques like removing stop word, special characters, HTML tags, symbols, etc. Then we moved to lemmatization, stemming to reduce the vocabulary as much as possible. One thing which is very important here is the amount of domain-specific knowledge we leverage. So we had a list of models that we are allowed to sell for a vertical. What are the brands allowed in a vertical? What are the quantifiers that sellers usually provide in the vertical? Now, this domain-specific knowledge will play a very important role in improving the accuracy. It helps reduce the vocabulary to a much extent. Then we move to pattern representation or feature generation. Now, after pre-processing step, the product descriptions are still in text format. We need to convert them to feature vector which can be passed to the model or classifier algorithm. So we use TF-IDF for this purpose. Now TF-IDF stands for term frequency, inverse document frequency. It is mathematical or statistical feature which reflect how important is a term or feature in respect to the collection of documents. Mathematically, it can be explained as a multiplication of term frequency, which is a function of the raw frequency count of the term, and inverse document frequency, which can be explained as a ratio of total documents, in our case total description by number of description in which these terms occur. So we use TF-IDF for feature generation. Then we move to feature selection. Now all the features generated in the previous step was not actually important, or we wanted to mute features which are not useful, or they don't provide, they don't help improve the algorithm. So we tried out a few of the methods like chi-square test, which we finally used, or recursive feature elimination or information gain. So generally in the case of text-based classification, high dimension is the norm. And we found that chi-square worked best for us. Now chi-square is a statistical feature, or it tells the probability of what is the probability that this vertical and this feature might occur together. It is used to determine the independence of two terms. In our case, a vertical or a class and the term. Then moving to classification. So we use multi-level hierarchical classification. Now all my leaf nodes are vertical. All the leaf nodes are vertical, and every non-leaf node is a classifier. Now at the top level where we have super vertical, health and beauty, when we pass the description, it decides whether it will be a fragrance or a body cosmetic, which are vertical groups. Suppose we take example of, this is example of perfume vertical. Now when we pass this description to our model, at the first step it should decide fragrance as the vertical group, then perfume as the vertical. So moving on to result. So as Ravindra sir already told, we trained our data, our model with Flipkart data, but tested with both our own catalog and public domain aggregators. So these are the results which we obtained for some of the aggregators on following on these verticals. So as you can see, we had as high as accuracy as 96% in the case of lipstick. We also had pretty decent result on our own catalog. You can see at super category level, we had an accuracy of around 93, followed by 92%. So I would like to summarize part one by saying that we presented a novel method to classify text description into verticals. We made one point which is very important here is the amount of domain-specific knowledge we leveraged. Yeah. And in future, we would like to introduce some deep learning aspect to it. Okay. Now call Ashendra for the second part of the talk, and we'll take questions after both talks together.
Yeah. Good afternoon, everybody. So in the next talk, we'll be so till now we have talked about how we use machine learning model for onboarding a product into our system. We talked about why a vertical entity was important. Now, once a product has been onboarded in our system, how do we use machine learning model to improve the performance, improve the experience of the customer, so that they can easily browse through the exact product that they are looking for, and how we can improve his experience on that. So overall we'll be talking about what is the problem statement that we are trying to solve, what are the challenges that we face in this classification, the categorization that we do, what is the approach that we use for this classification, what are the results we obtained out of it. We'll compare it with the existing baseline methods that are there in the industry and how we have performed better than that. We'll take some real examples, some real description from the Flipkart site and see how they have performed on it. And in the end, we'll summarize the overall approach and how it has helped. So the problem statement is very simple. Just there is a description. So for example, in this case, so in this case, this is a description talking about a character Mary Leaper on a book which is titled as a work of Mary Leaper. So this is a poetry book under literature and fictional category. Now for a user, so are there any book lovers in here? Right. So I'll ask any one of the book lover, when you finish up with a book, what do you do on an e-commerce site and how do you search for a new book? So yeah, so what she will try to look is that she will try to look for a genre, and within that genre, what are the books available on the site. So identifying the correct genre, identifying the correct browsing category of the books are very important. So this solution will be mostly talking about on book catalog only, how we solve the categorization problem for book. So as she said, genre is very important. If we classify a product into a wrong genre, she might not be able to reach up to a product of a particular genre ever, because she will be always looking into the genre and then she will not find it correctly. So that is the exact problem statement that we are trying to solve here. So what are the challenges that we face while doing the product classification? So one of the major challenges that the data we have in our systems, all the categories, subcategories are very skewed in data, in the distribution. So what I mean by that is, so this is like the tree map of the data that we have in our system. I guess it is not very much clear to the audience, but what it is highlighted over here is that we have a literature section here, which has, so this is talking about how many products we have in each of the category. So we see that literature and section have this much block of products in the overall space. There are sections like children and all, which are smaller in number. And even if I double click on literature and section, then there will still this skewed distribution there. That humanities still is covering more of the catalog than any other section like computer or internet or mathematics also. So if we will take a random set of the catalog and try to train our classifiers and try to predict output from them, then they will be biased to the category which is actually trained more. So how we solve for this is that while preparing the data, we we pick the equal sets from each of the categories and the subcategory, so that the models we learn are actually learned well. The other problem that we has is the constraint in an hierarchical classification. So as it is, as you see the classification here in books, there is a literature fiction and health and fitness books, and within literature fiction there is poetry, horror, and within health and fitness there is wellness and diseases. So now if my model predict that wellness, this is a wellness category book, and my supermodel is predicting that literature fiction is a super category, but both of these predictions do not make any sense, because a literature fictional book cannot be a wellness book. So this is the constraint that comes up in the classification. How we solve for this, we'll talk about in the approach that we used. So here, in this section I'll be talking about the solution. The solution and that we'll talk about will be split into two parts. So the first part is how we represent a description and title into a machine learning terms, or we call it as a vector, and how do we, using this document, this vector, the description vector, how we use this to train our models, and how do we do the final prediction. So here it's a description of two books. So one is an Harry Potter book and another is a NTSC book. Similarly, we collect description of all the books in our systems and we create a corpus of the words. So corpus of the text words, and from those corpus we try to, so we use a skip n-gram model to represent each word into a word vector, and then with each word vectors we cluster them. So we form different clusters of the words. So each cluster is semantically saying that these words are close to each other. These words have relatively similar meaning, or they exist together in the system. So in this, once we have a, okay, so once we have this clustered data, when we have actually from the text corpus we have actually created cluster of the words. Now any given document, so can anybody recognize what description is this about? Can it? Yeah, so yeah, I know people will be knowing Game of Thrones a lot. So it's a Game of Thrones book description. So given a description of a book, we try to represent it with a document vector. So the document vector will be represented by different cluster, and in each cluster how importance were there with the words, like what all words existed in that cluster. And so what is another thing that is to capture here is that the words which are semantically different, we do not average them out. We keep different vectors for each cluster. And if you capture this part, it's called a graded weighted. It's not just a normal bag of words. The why it is graded weighted, because for each of the idea, so as we talked about inverse document frequency, the significance and the importance of the word is captured in the idea value of the words. So for each of the idea values of the words in a cluster, we also capture that information in our document vector. So that's why it is a graded weighted method. There is no animation. Okay. So I presented it as an animation because this is a lot of text. Okay. So this is the overall approach, but I'll be talking step by step. So this is the input that we have. So we have a title and a description. Now, if you can see this part, so we have a 3 multiplication with title. So what it is denoting is that we understand that title is more relevant in figuring out the classification. So we give it more weightage. We say that the title is 3 times more weightage than the description, and this we have done after our experiments and all. This we figure out after our experiments. So once we have this title and description and we have converted into a document vector. So document vector is converted, so this abbreviation is for graded words of bag of words vector. So once we have converted our title and description into a document vector, so we parallelly provide it to multiple classifier. So the first classifier is a path prediction classifier. It's just trained on a document vector, and it is trained given a document vector, what are the paths it will predict. So from the previous, if we go in the previous example, given this description and the title, which I've hidden actually here, key what is the path, what is the actual whole super category and the subcategory of this product. It will predict that part of the classification. In the second classifier, the node prediction classifier, it is trained that all the document vectors that we have, what are the output labels it can have. So in this case, what can happen is that the previous challenge that we talked about, where we are having, where we talked about that we can predict a subcategory as wellness and category as literature fiction. So that challenge comes in that second classifier, that the node prediction classifier. But the classifier is just given a document vector, what are the node labels it will have, and what are the probability of each of the node labels. In the third level classifier, it is a depth classifier. So at every depth, we have a classifier, and which says that at this level, at this depth, what are the nodes that will be predicted. And we will be similarly having different depth classifier. So in our Flipkart catalog, mostly there are products which actually either have subcategories up to 4 or 5 levels. At max, we have 6 depth in our Flipkart catalog for books. So we have 6 depth classifiers. So each of these classifiers output us the probability that given the document vector, what are the paths, or what is the node, or what is the node at this particular depth. So we have a set of output probabilities from each of these classifiers, which we concatenate with the original document vector, and we form a very high dimension feature vector out of it from the same original document. Now this has, as the number of subcategories we have in our systems span around like 4,000 to 5,000, and each of them predicting over the same probability, the overall dimensions grow up to 15,000. So we reduce the dimension using the ANOVA mechanism, which is analysis of variance. We just see what is from all the output predictions, what is the variance that is there, and try to reduce the dimension from the variance. In the dimension, in all the dimensions which will have low variance, it will just skip out those dimensions. Once we have a reduced feature set, when we have a reduced feature vector, from that we trained our second level classifier, which on the basis of this reduced feature set, what will be the output path, what will be the exact output path. And we use this second level classifier to predict the final probabilities of the top paths. This is too much of information, but if anything is still not understandable, I can repeat again. So is there any doubt on this? Okay. So that was the overall approach we use in classifying a particular book product in our system. These are the results that we have. So we call this approach as assembling technique, so which is like parallelly doing things. We use 2 evaluation metrics to evaluate the result. One is the count precision and another is the label recall. So count precision talks if I predicted top 6 paths, out of this top 6 path, is any of the path original path or not. Secondly, label recall talks about if I predicted 6 paths and in those 6 paths there were 10 labels that I have predicted, those 10 labels, out of how much percentage of those are there in the actual path. So that's what the label recall. So TF-IDF is a baseline approach on which we compared our results, and path prediction is a simple plain path prediction, and multi-type predictor is when we use both level 1, level 2 and multi-level 1 classifiers. So we've seen a little bit improvement over the baseline method. Like in the count precision, there's an improvement of around 2.26%, and even in label recall, there is an improvement of 2% around. So overall, we have done a bit, but there is still a long way to go. But we are trying to solve this problem. So this is an example, real life. This is another description of a book on a reptile and amphibian, and it's an academic book. So this is the actual path of this book, but our model has predicted 2 paths, and it has a probability associated with it as well. Though one of the path is the actual the path, and the other path is a different path, which is saying it is a fun and humor book. So the model has corrected a correct path, but it has a low probability. In another example where it is a humanity book on science reporters, and the actual class was a academic text under humanities. Our model has predicted this as one of the paths and some other paths as well, but the probability is very low. It's like not even 10%, it is 6.7%. Though it has predicted another category which is dummy, which is with a high probability. So this is overall the solution was, in future what we are trying to work on is also, first of all, the whole prediction mechanisms take a lot of time. So we are trying to parallelize many things. First of all, the conversion of the documents into a document vector and the clustering happens sequentially. So we are planning to parallelize that work. Secondly, the current clustering mechanism that we use is a k-means clustering, so which is a parameterized method. So given a k, it clusters. So we are planning to move to a Chinese restaurant process clustering mechanism where it automatically identifies how many clusters it found. Thirdly, that the topic modeling in the document vector is a static. It's like either a word belong to a particular cluster or it does not. So in a GMM based composition, it can be partial. It can like 40% of this word belong to cluster 1 and 60% of the word belongs to cluster 2. So as I summarize the talk on this, and I will take on questions after that. So here we proposed a very compositional technique to form a document vector out of the description, and it not only captures the words that are there in the document, it also captures the distinctness and the importance of the words. Secondly, the classifier that we have used has helped us. It's a multi-level and different type of classifier that we have used in this approach, and it has reduced the classification error by some percentage. So this is the same work that we have also submitted in a calling conference, which has been accepted. Any questions that the audience would have? Yeah. Sorry, timely? Hmm. Hmm. Okay. Hmm. Okay. Hmm. Right. Hmm. So I'll repeat the question to the larger audience. So what he's trying to, the question is, so we have learned the models on the categories which are there in our system, but in future there will be products that will be coming up which are not existing in the existing categories. So how does this model capture that part? Does this model capture, these models capture that this type of product does not belong to any of the categories, and we need to create a new category for that. So um, to answer that, I'll say, so from the seller point of view, what happens is that those requests comes from the business that a new category is coming up in our system and we need to launch that vertical into the system. From a customer point of view, what happens is that a customer will see that product in a higher category which we will be having. So for example, you are talking about an ultra phone, so which is again in part of a smartphone only. So it will be categorized into a smartphone till the point we create that subcategory of ultra phone, and once that ultra phone category is also created and our models are again trained on that ultraphone, then our models will work with that as well. So the models will not be able to predict that. So models will not be able to predict that it is an ultraphone product, but it can say that it is a smartphone, and I cannot categorize it further.
What Ashendra has said, typically we need training data. So for example, if you go with model 1, when we are trying to classify a given data belonging to vertical 1 or vertical 2, we are making an ensemble of all the products that are falling in the vertical. There is imbalance. For a moment you forget about imbalance, that as an ensemble only it will learn that from whatever is learned, it will be able to classify. If you want to surprise the system, it will misclassify. So unless you have enough data, I know you won't be able to understand that. Possibly it will misclassify. Unless there is enough data, like you said, you also said that, unless many people are calling it that way, I won't be able to learn. That system is not going to learn. It will have difficulty.
So Ashendra, one question here. So here for books, maybe this technique was more amenable because you have a lot more in the description. Have you thought about other categories? You need deep learning. That is number one question. Second is the improvement you showed in terms of precision recall. Does it justify the cost? There's obviously probably there's a performance penalty or more resources, GPU machines and stuff. Do you have any insights?
Yeah. So answering to the first question, did we try this approach on other categories? Yes, we did. We got a much better performance from using just a single path prediction classifier in cases of other categories. But for other categories, the problem is very simple, because for the other categories, we have not only description, we also have certain attributes which can decide the browsing behavior. For example, if I take an example of a t-shirt. So within a t-shirt, I know that this t-shirt is either a men t-shirt, is it a woman t-shirt, is it a kid t-shirt. Also, I know whether it is a solid t-shirt, it's a strip t-shirt, or I even know the brand of the t-shirt. So I can actually form the browsing classification just from those information. I actually don't need machine learning tools for those. So yeah, we have tried that. It has worked also better, but we are not planning to use those techniques in our Flipkart catalog currently. To answer to the second question, now I forget the question. Sorry. Performance. So the second question was ki the improvement that we have seen is not much, and is it worth the efforts that we have done? So in machine learning industry, it's like every percentage counts. It's like that. So though we have improved by 2.5% only, but we're still working better than what they're in the industry. So any other competitor is not doing better than us. So I'll just answer in that terms.
You told that you use k-means for clustering. So what's the approach you take to identify the number of clusters?
So we experimented with different number of clusters. So if you see the dimension in the result section, we had different dimensions talked about. So these are the variants on the number of clusters that we used in our for our technique. So if we tried on 40 clusters, we tried on 60 clusters, we tried on 80 clusters, and whatever gave us a good accuracy, we used that finally.
Guys, we're breaking for tea now. Y'all can catch up with whatever other questions outside. Thank you so much.
So we have an...
Yeah, the best question actually gets an award. Which one was it?
Yeah.
Who is this?